Hello students, welcome to the next lecture on the differential equation. Today we will discuss about the various examples for solving the differential equation with the help of variation of parameter. We will try to explain all these 16 examples in this lecture. Myself, Dr. Garg. You can simply follow my YouTube channel Dr. Harish Garg, where you can find the various lectures on this differential equation. What we have discussed in our last lecture, we have described the method of the undetermined coefficient for solving the differential equation of here, where r of x is either of the exponential form or quadratic or polynomial or of the trigonometric natures are there. All these previous lecture available at my YouTube channel Dr. Harish Garg. However, if you are looking about this r of x instead of this polynomial trigonometry or here, we will see these 32 examples we have discussed in our last lecture, which is available in this here. Now what will happen if you consider this r of x as log x or tan x or 1 over this, or you can say 1 over x and so on, then this method of the undetermined coefficient does not applicable to solve the problem. That's the limitation of this undetermined coefficient. To overcome this cases when r of x is either of these case, we will try to learn the concept of method of variation of parameter. That is, whenever you have the differential equation of this, where r of x, it could be of log x, tan x or here, or it could be of the x square plus 1 or there, then we can apply this variation of parameter. Whenever this r of x is my non-zero, then we all know the general solution will be decomposed into the two parts. First one is the complement solution, second is the particular solution. This yc you can easily solve by taking the homogeneous part of the differential equation, and after solving you will get as c1 y1 plus c2 y2r. How you can find the value of the yp? That is, there are the two different cases are there. The cases are there when you have the leading coefficient, that is a y double dash is a 1, or when the leading coefficient is not a 1. What will happen if it is a 1 and if non-1? If it is a 1, then you can find the particular solution by using this formula, where y1 and y2 are the solutions of this homogeneous differential equation, where w is called as the Wronskian, that you can simply written as y1 y2 and their derivative. If you have, say, it is a c3 y3 also, then you can define the Wronskian as y1 y2 y3, take their first derivative y1 dash y2 dash y3 dash, and then take their second derivative, where it's a 3 cross 3 matrix are. If it is a 2 cross 2, then you can write like of here. What will happen case 2, when your leading coefficient is non-1, then instead of this here we will divide it by a in the denominator. So these are the simple rule about this variation of parameter. We will try to explain all these 16 or 15 examples in this lecture. So let's start with this first one. Clearly says that the leading coefficient is my 1. You can see the leading coefficient is 1 and the coefficients are my constant. So once it's a constant, you can find the general solution in these two ways. And clearly says that it's a cosecant are there, so the method of undetermined coefficient not applicable. So we can work on the variation of parameter. Firstly, we will try to find the complement solution yc. How you can find the complement solution? We can define the auxiliary equation, that is the m square plus 1 we can get as m is plus minus iota. So what is the complement solution is? Since it is a complex number, we can write in the term of cos and sin. Therefore, your y1 will be my cos x and y2 will be my sin x. Now, in order to apply for the cosecant, we have to apply the method of the variation of the parameter. So for that, we have to apply this one, because the coefficient is my 1, so I can written here. What is my w? W is nothing but my y1, y2 and y1 dash and y2 dash. So I can substitute here. Y1 is nothing but my cos x. This is sin x divided, and second row is my sin and cos b. So clearly say that if you take this, the determinant, it should be 1. Make sure that the Wronskian is always be a non-zero. If it is a 0, then you have to check your calculation. Now you can substitute this value. This is my y1, I can substitute here. This is my y1 and so on. What is that? This can be cancelled out. So it is my cos x, it is 1 plus sin x. What is that? This is 1 over sin, that is nothing but my cot x of dx. Now after that you can simplify this. This integration of this is my log of sin x, integration of this my x. So you get the yp, you get the yc, you can substitute here, you get the final general solution of this equation. Look at the second example. Again you can see the coefficient, the leading coefficient is 1 and this is my constant coefficient, so we can find the general solution in here. Clearly say that because of this secant here, the method of the undetermined coefficient is not applicable. We can write the general equation firstly for the auxiliary, that is m square plus 2m plus 2 is equal to 0. You can solve them, you will get as minus 1 plus minus iota. Based on this you can define the value of the yc, which is nothing but my here. Now since the leading coefficient is 1, we have to apply the method of the variation of parameter, which is here. What is the Wronskian? This is because there are the two solutions, y1 and y2 divided, second row is my here. What is my y1? What is the coefficient of the c1 is e raised to power minus x cos x. What is y2? Coefficient of the c2, that is e raised to power minus x sin x. I can substitute these both values at here and here. After that we can solve this, we will get here. Clearly say that this is my non-zero. I can substitute this value here, which is a minus e raised to power minus x cos x. Integration y2 is my here. Now how you can simplify this? E raised to power minus x cos x. Now you can see this is cancel out. Now it's a sine and it's a secant, so it's a sin x divided by cos cube x. Similarly for the second part it will be cancel out and you can write like here. How you integrate them? If I take if I simply take tan of x is my t, then is a secant square x, dx is my dt. So this is my t. So what is the integration of this? It's t of, that is my t square over 2, that is a tan square x by 2 is the integration. What is the integration of this? That's nothing but my, what is the integration of the secant square? Secant square is nothing but my tan xb. So this is sine r. Now you can simplify that, you will get here. You can take e raised to power minus x sine square is a common, and after that you will get as of yp. So what is the right answer is, what is the general solution is, yc plus yp is the right answer of this problem. So this is the final answer. Now look about this one. Now you can see the leading coefficient is not a 1. So how you can find the general solution of this problem? Since firstly you have to find the homogeneous part, but you can clearly say that this equation, can you tell me how you can solve this equation firstly? Yes, this is a Cauchy-Euler equation. So once it's a Cauchy-Euler equation, how you solve that? We all know that we can take x is e raised to power z. So z is nothing but my log of x. Therefore you can take the substitution x y dash and x square y double dash. What is the x y dash is nothing but my dy, and this is my of here. What is the d is derivative of z. So this is the substitution of the Cauchy-Euler that you can solve it. I can substitute here. What is the value of this is d of d minus 1 y plus, what is the substitution of this is dy minus of y. I can take x is equal to e raised to power z as here. So this is e raised to power 2z, and e raised to power x, what is the value of the e raised to power x? E raised to power of e raised to power z. Now you can simplify this, this will be here. Now clearly say that the coefficient of the d square is 1. What is the meaning of the d square is? This is my here minus y e raised to power 2z e raised to power. Now you can see the coefficient is my 1 and they are the constant. Once they are constant, you can find the general solution, which is my plus 1 and minus 1. Then you can write in terms of the here, you will get this, and you can substitute x is e raised to power z, you will get here. Now this is here. Now how you can solve this yp? There are the two methods, because the leading coefficient is not a 1. But how you can solve, that's why there are the two methods. The first method is either you can use this differential equation, say equation number 2, or you can solve this differential equation for finding the yp. That's why there are the two methods. If you look about this differential equation, the leading coefficient is my 1. So then you can use as here corresponding to here. But if you look about this second method, that is if you look about this, the leading coefficient is not a 1, then you have to use this as a. So look at that, the leading coefficient is 1 in terms of the z. So that's why I have written here as a dz. But here I have taken as a leading coefficient a of this equation number 1, which is in terms of the x, so that's why this is a d of x. So that's choice on your side. If you look about this part, then what will be the Wronskian is y1 y2, but it in terms of the z. So in terms of z is my here, what is the y1 is e raised to power z, y2 is my e raised to power minus z. So I can substitute here as of this, which is a non-zero. If you look about this part, then it is in terms of the x, then your y1 will be my x and y2 will be my 1 over x. So that will be my x 1 over x, and you can write here, which is again a non-zero, because if x is infinity, this equation is meaningless. So that's why x can never be a 0. So now once you are here, so there are the two methods, we can solve either of them. So if I use here, that is by using this part, your r will be my right hand side, y1 and y2 will be my, this is my y1 and this is my y2. I can substitute here. On the other hand, if I taking about this one, then your r will be my here, a is my x square, you can see this is my a is my x square, r is my x square e raised to power x, y1 and y2 are my x and ex. Now if I just try to solve this part, what will happen? 1x will be cancelled out. So what is that part? This will be goes as here. Now what will happen if you solve them? The integration of this is my e raised to power x, integration of this is nothing but my here. So once you can solve them, now you can open this bracket, you will get as of this as a yp. If you would look like to solve this one, you can see this minus 2, this is minus of 2, and this can be adjusted here. How you can integrate them? If I simply take e raised to power z as a t, then e raised to power z of this is my here. So you can see this is my dt. So this integration will be my e raised to power t of dt, that is e raised to power t of this. So the integration of this is my e raised to power of this. How you can solve this part? Again, you can take e raised to power z as a t, e raised to power z dz is my dt. So I can substitute here, it will be my t cube e raised to power t. What is the dz is dt over t. So 1 is cancelled out, so it's a t square is of this. Fine. Now you can integrate this again by parts, which is written as here. I can substitute this value in, so t is nothing but my e raised to power z, and e raised to power z is always be a x, as we discussed in the Cauchy-Euler, because x is e raised to power z, which is nothing but my t, so I can use as here. I can open this bracket, which is the same solution, and finally general solution will be yc plus yp. Look at the another one, which is the constant leading coefficient is 1, but you can see this again, the method of the undetermined coefficient is not solved. You can find the general solution, that's very simple for the complementary part. For the particular solution, since the leading coefficient is 1, we can take an as here. y1 and y2, this is my y1, this is my y2, clearly says that the Wronskian is a non-zero. I can substitute this value as here. I can take 2 as a canceller, this minus and minus plus, and here. How you can integrate them? Firstly, I can take this integration. How you integrate this? If I take e raised to power x is my t, then ex dx is my dt. So this integration becomes my dt over t, that will be my log of t, that means log of 1 plus e raised to power x. So the integration of this will be log of e of this. Now how you integrate this one? That's again a very simple. Again, if you take e raised to power x as a t, then ex dx will be my dt. So it means d of x is my dt over t. So if I substitute here, it will be 1 over t, 1 plus t, dt over t, that's a 1 over t square. That is my here. Now how you can do that? You can simply take as a partial fraction, that is my t square, t and 1 plus t. This is my dt. Now how you can take the base of partial fraction, you can convert them into here. Now what is the integration of this? This is minus 1 over t, it is log of t, it is again log of 1 plus t. So I can substitute the value of the t as e raised to power x. So I can this is the value of this in this part. I can substitute this value here, multiply with e raised to power x, you will get here. I can open this bracket, this is my yp. This is my yc, this is my yp. So the final solution will be yc plus yp. Look at the another one. So again, this is the general solution. Again, you can see because of this log of x, the method of the undetermined coefficient is not applicable. So firstly, we can find the yc because the leading coefficient is 1. They are the constant coefficient, so we can write like of this form. Because the leading coefficient is 1, so we can simply write here. What is the value of the y1? Coefficient of the c1 is, if you multiply them, it's e raised to power x. What is my y2 is x e raised to power x. So what is the Wronskian is, if you write the Wronskian as e raised to power x, x e raised to power x divided by their derivative. So that will be x plus 1 e raised to power x. So if you open this bracket, you will get as e raised to power 2x, which is clearly say that's a non-zero. Now I can substitute the y1 and y2 at here. Now how you can solve that? This is e raised to power x cancel out. This is e raised to power x cancel out. So it will be x log x, and here I can take this as first function, and this is my second function. This is first function, into of 1 as a second function. So I can integrate by parts, because all of you know that how you can integrate this by parts is first function, integration of second, derivative of first function, integration of second. So that will be here. Now this will be my x. Again it will be integrable. It is a 1, so it can be as of the x, and here after just open this bracket you will get as of this solution. So this is my yp, this is my yc, yc plus yp will be my general solution. Look at the another one. Now again, because of this 1 over x, this method of the undetermined will fail. So we can firstly find the general solution corresponding to the auxiliary equation, which is here, and because the leading coefficient is 1, we can write like here. Again the y1 will be my x e raised to power minus of 2x, and here you can find that determinant which is a non-zero. I can substitute this value here. I can open this, I can see this value will be cancelled out. It's a e raised to power minus of 2x. I can open this bracket, I can take this part which is written like of this. Now how you can integrate this? This is by parts. Integration of 1 will be my x. You can see this is by parts. Integration of 1 will be my x. This is integration of e raised to power 2x by 2. Integration of the 1 by x is my log x. If you open this bracket, you will get this calculation. Minus 1 by minus 2x plus 2x will be cancelled out. You will get here. So this is my yp. Yc is my here. Yp will be mine. Now this is the required answer. Or you can also simplify that. If you open this bracket, there is a one more term of the x ex. So I can written as x of this plus x e raised to power minus of 2x common. It will be c2 minus 1 plus 1 plus x e raised to power minus of 2x of log x. So I can consider this c2 minus 1 as another constant called as c2 del. Otherwise that's a skip for here. That will be fine for you. Okay, look about this one. So again the coefficients are not constant, but how you can find the general solution of homogeneous part? This is my homogeneous, but clearly say that is it a Cauchy-Euler? No, it is not a Cauchy-Euler, because if it is a Cauchy-Euler then it must be of the x square at here. So it means you can't substitute x as e raised to power z. It means how you can find the general solution? Again the coefficients are not constant, so but you can take x as a common on both sides. That will be here. Now you can see these are my constant coefficient. You can easily find the value of the yc from here, which can be written like of this method. Now you can see the coefficient leading coefficient is 1, which can be written like here. What is the y1 is e raised to power x, y2 is my x e raised to power x. You can find the Wronskian corresponding to this y1 and y2, which comes to be e raised to power 2x, which is a non-zero. I can substitute this value, but make sure that what is the r is my here. Why? Because if you consider r is my here, then the leading coefficient is not a 1, then you have to written as a on this side. That's on your choice. So I can substitute this. You can see e raised to power 2x will be cancelled out, e raised to power 2x will be cancelled out. So it is e raised to power minus x, x will be cancelled out, so it will be here. What is the integration of this? This is the x. Integration of this is my log of x. So this is my yc, this is my yp. I can add them, you can get the right answer. And you can see this is the x ex, and there is a one more coefficient. If you combine them, it will give you a C2 plus 1 x e raised to power x. So I can take as a C2 dash is another constant. That will the right answer. Look at the another one. Again you can see because of this 1 over x square, the method of undetermined coefficient is not applicable. We can firstly solve this auxiliary equation, which is written as 3, 3. Leading coefficient as a 1, so it can be written like here. What is the y1 is? Now in this case y1 is e raised to power 3x, y2 is x e raised to power 3x. We can find the Wronskian and check whether it's a 0 or non-zero. Make sure that it is always be a non-zero. If it is a 0, then you have to check your calculation. Again the leading coefficient is 1. I can substitute this value here. E raised to power 6x will be cancelled out. E raised to power 6x will be cancelled out. So it is my here. It is 1 over x dx plus x e raised to power 3x, and it is 1 over x square. So what is that? 1 over x, integration of this is my log of x, and integration of this is my minus 1 over x is the right answer. So this is my yc, this is my yp. You can add them, you will get the right answer of this problem. And you can see if you open this bracket, c1 minus 1 e raised to power 3x, I can adjust this value with the first constant and the rest values are my same. So I can take the first part as a c, another constant, c1 minus x, c1 minus 1 is the another constant as a c1 dash. Okay, look about this another question. Again, because of this 1 over 1 minus x whole square, the method of the undetermined coefficient is not applicable. First target is how you can solve this homogeneous part. Clearly say that this is my Cauchy-Euler. This is the Cauchy-Euler. So you can take the substitution as of this. So once it is here, so you can substitute x square as my d of d minus 1 plus 3 times plus of y. Right hand side is x. What is the x is? E raised to power z whole square. Now you can see. Now this is the constant coefficient. Based on here you can find the value of the yc in terms of the z. You can convert them in terms of the x. Now again there are the two methods for finding the yp. One is when the leading coefficient is not 1, that is because of this. If you are using this equation number 1, leading coefficient is not a 1, so you can write a. Otherwise, so you can find this. If you are using this equation number 1, because the leading coefficient is not 1, so you have to write a. But make sure this is in terms of the x, so you have to written as a x. If you are using this equation number 2 for finding the particular integral, which is in terms of the z, so you have to written here as a dz. So make sure that. And here the leading coefficient is 1, so you can written as a as a 1. So that's depending upon you. If you are using this, then what will be your y1 for finding the Wronskian? What is the y1? This is in terms of the x, so you can written here. What is the coefficient of the c1 is 1 over x. What is the y2 is log x over x. If you are talking about here, then what is the value of the y1 is in terms of the z. What is the coefficient of the c1 is e raised to power minus z, and y2 is z e raised to power minus z. So that's depending upon you, which either of the method you can use them to. So if we are using this firstly x, that is I am using this equation number 1, I have to find the value of the y1 and y2 from this here, that is 1 over x and log x by x. So clearly say that which is a non-zero. Why? Because if it will be 0 only when x is infinity, but when x is infinity, this differential equation is meaningless. Now once Wronskian is non-zero, so for the second case, if you are talking about the z, then you have the y1 and y2 from here. Again it is a non-zero. Now you can substitute here. If you are using in terms of the x, then your rx will be, this is my r. What is my a? A is my x square. If you are here, then your r will be my this part, and a is nothing but my here. So I can take here y2 will be my log x by x, r will be my here, a is my x square, Wronskian is my 1 over x cube. Similarly for this side, y1 is my this is my r, and Wronskian is my this one. Now you can solve either of way. For example, if I try to solve this portion, you can clearly say that this is 1 by x, this will be cancelled out, it's a log x over here. Again 1 by x, and this 1 by x will be cancelled out, it will be here. How you can integrate them? That's the integration of this is very simple. You can take as a 1 minus x minus 2 plus 1 over minus 2 plus 1, derivative of 1 minus, here this is a minus 1, so it will be plus 1 over 1 minus of this. The integration of this will be here, that is my here. How you can integrate them? You can use the integration by parts, that is the integration of the first function, integration of this minus derivative of this 1 by x, and integration of this is there. Now how you can integrate them? You can simplify, open this bracket, you can see this part will be cancelled out. How you integrate them? You can take the partial fraction. How you can write this partial fraction? X, so you can take x as a 0, so apart from this substitute x as a 0, it gives as a 1. If you take this as a 0, x will be 1, substitute x is equal to 1 everywhere apart from this term, so it's a 1, so you can written like it. Now what is the integration of the 1 by x? Is a log x. Integration of 1 over 1 minus x, it will be log of 1 minus x divided by their derivative, that's a minus 1. Now you can written like of here, this is my yp. If you are using this method, then how you can integrate them? This will be cancelled out. I can simplify this, written as here. Now how you can solve them? Firstly I can try to solve this part. I can take e raised to power of this, say y, or say instead of the y it's a t, then minus e raised to power z dz is my dt. I can substitute this limit as here, it is a minus dt over t square. What is the integration of this? Is 1 over t. So what is the 1 over t is? That is a 1 over 1 minus e raised to power of this. How you can integrate this part? So clearly says that again, if you take the substitution, or else you can take e raised to power z over 1 minus z of this as a first function, this as a first function, this as a second function. So I can integrate this as a first function. Integration of, you can see how you can integrate them. First function, integration of this part minus derivative of this, that is a 1, integration of this part. So this integration we already compute that is 1 over 1 minus of this. Now you can open this bracket, this will be here. How you can integrate them? Again, that's a very simple. You can take this as again t. So what is that? E raised to power z dz is minus of dt. I can substitute this value here. This is t, and dz is my minus dt over t. That's fine. And sorry, it's a 1 minus of t. So you can simplify this here. How you can solve them? Again, you can take the partial fraction, that's a t, and it's a 1 minus t. If you take t as a 0, it will be 1. If you take t as a 1, it will be my 1. Now you can integrate them, you will get as of this. So this is the integration of this part. I can substitute this value here. What is that? E raised to power z is my x, this is my 1 by x of this. You can see both the answers are same. So this is my yp, this is my yc, so the final answer is yc plus yp is the required. So this is the way you can solve this RQ. So these questions are exercise for you. Few questions we already described that, like this we already explained in this we already explained them. Many more are there. Rest you can try to solve yourself. These are the answers of the first 8 questions. These are the answers of the other 7 questions. You can try to solve these questions. I hope you can simply learn this concept simple way. Kindly like, share and comment on this video with your friends. Best of luck students. Happy learning. Thank you.